Let's take a look at some commonly used tools. The toolbox is located in the settings on the right. On the display page, you can also open it by showing or hiding the toolbox. In the toolbox, we want to focus on the function of merge data, because current software has a chunking process for data processing. If the collection time is too long, the processed data may be quite large, which requires higher computer performance. If chunking is done during the processing, it can reduce the pressure on the computer when processing data. You can see that this data now has two chunks. Then through this merging function, you can output these two chunks of point clouds as one point cloud. Open the merge data function. The software is set to automatically select the point clouds of the activated project. Note that the merge function is mainly targeted at the projects we have activated. In the catalog tree, the green project indicates that this project is activated. Then click OK. Wait for it to finish outputting. After the progress bar ends, it will prompt us whether to add it to the project. If you click Yes, it will be added to this project. Here we click No. Then take a look at another function. Click No afterwards. You can add the point cloud we need to the current project with this Add button. Click Add. Then select the point cloud we just merged. Click Open. Click OK. The software will create a new project with the current time. Then the merged point cloud will be in this project. You can select 2 point clouds from the original project by holding the Control key. Display according to the selected color. Open EDL. This will make the comparison more pronounced. The recently merged point cloud can also be displayed according to the selected color. In addition, the Add function allows you to add reference point clouds for comparative analysis. For example, assuming this merged point cloud is the reference point cloud, then you can draw a profile in the tool to see the relative accuracy of the 2 point clouds. We just introduced the merging function in the toolbox. In fact, the toolbox has some other functions as well. For example, common point cloud extraction and export, as well as projection and coordinate transformation, and other tools. We can refer to the user manual. The user manual contains detailed introductions. Next, I will focus on introducing some tools under the Tool tab in the calculation interface. Click on the pick point. We can see the coordinates, intensity, classification, time, and other information of this point. The pick multipoint function allows us to click on multiple points. The pop-up window will display the information we selected. Clicking Save will save it to the 3D point. Open the path we just saved. We can see the points we just selected. Next is density. In density, we can set a rectangular area with a side length of 1 meter. Clicking on the point cloud allows you to see the number of points in this 1 square meter area. There are also some measurement tools, such as length, area, angle, etc. We can directly perform measurements in the point cloud project. There is also volume measurement. You can manually select a range to measure the volume within the selected range. Profile function. You can view the thickness of our point cloud and the condition of the building facade through the profile. By selecting here, we can select the point cloud using polygons or other selection methods. For example, first select the point cloud here, and then click the In button inside Cut. This will allow you to clip out the selected point cloud separately. Then click Save. This will allow you to export it as another point cloud. If you don't want this clipped result, you can directly click Cancel to restore it. If we have selected some extra areas, for example, like this, you can use the Subtract function. Cancel the selection of a portion of the point cloud. Use the outer clipping function to retain the unselected point cloud. Then we cancel. Next is the cross-section and the horizontal section tool. Cross-section tools can be used through bounding boxes. Selectively display the point cloud. For example, here. Filter out all the point clouds above. Only keep the point cloud below for comparison. This is applicable in forestry or indoor architecture. Can remove the tree canopy or roof. Facilitates our view of the tree trunk and indoor data situation. The horizontal section tool is similar. However, it only takes one section. It is more user-friendly for displaying the planar contours of point clouds. Next is the export function. The export function exports the point cloud into various formats. For example, exporting to commonly used formats like loss or others.